Hi everyone, welcome back to Farmside, the show where we go into the science and education behind farming. My name is Emily Stein, and today we'll be talking to Dr. Nevin Lawrence about weed competition and how it relates to his studies as a weed scientist. So sit back, relax, and let's go find out all about weed competition. So Nevin, can you explain what weed competition is?
Weed competition is simply the negative impacts on fitness to a plant caused by neighboring plants of another species. And this is most easily understood in the terms of crops, with crops being competed against for resources by weeds.
And what is it that weeds compete for?
Usually when we talk about weed competition, weeds and crops are competing for water. So especially in dry land agriculture where you might not have enough water for optimal crop yield, when weeds are using some of that available water in the soil profile, you can have additional shortages to the crop. Nutrients, so fertilizer or just the nutrients that are naturally there in the soil. Sunlight, and so you can have a tall plant that's blocking some sunlight from reaching the bottom, and that's going to interfere with the optimal photosynthesis. And then sometimes also space is included in there as well, that they're running out of space because of the number of weeds in the field for a particular crop.
How early does competition begin?
So competition, when we think about it in terms of nutrient or resource competition, so they're competing for a resource, that has to occur. You have to have a limited resource for the competition to be happening. So if we think about planting a crop, let's say corn, and you're going to put in a starter fertilizer, well, the corn is not going to be using all of that fertilizer right away. It's going to have to get to a certain height before it's starting to need, let's say if you're doing a type of farming where you're going to be doing 2 applications of fertilizer in, there's going to be a point early on in the season where it doesn't need yet, based on the growth stage, that second fertilizer application. So there's enough fertilizer, more than enough for let's say that corn plant in this example. So we can imagine early on in the season when we're preparing the seed bed, everything's just perfect, and the crop's just coming up. There's probably enough sunlight, space, water, and fertilizer for all the plants that are growing in the field, including the weeds. So we wouldn't think that nutrient competition or resource competition is occurring right early in the field, but we also do sometimes see yield impacts from early season weeds. But this isn't generally considered to be caused by resource competitions. Instead, it's caused by something called the shade avoidance response.
What is the shade avoidance response?
Plants absorb certain wavelengths of light, and they reflect other wavelengths of light. The reason why plants are green is because they're reflecting green lights. They're not absorbing that green light. And so when a plant is hit by sunlight and it sends off certain wavelengths, neighboring plants can detect the presence of that particular plant based on the reflectance or changes in the wavelengths of light that's hitting them. So in particular, what happens is plants are able to detect changes in what's called the red to far red ratio. So red light is the light that we see. Far red is red light that's on a wavelength that we cannot see. And so those changes in red to far red ratio, plants can detect that. And those changes occur because of neighboring plants, either the light reflecting from the plant to the soil or to the neighboring, just directly to the neighboring plant, but they can detect that. So plants can detect the presence of other plants nearby. And just the simple act of detecting those other plants nearby causes what we refer to as a shade avoidance response. So what they're trying to do, the plants, is once they know that, okay, there's another species nearby, is they're going to try to grow in a way to avoid being shaded. They don't want to be the lowest plant in that canopy. So they're going to try to grow taller. And so this is called the shade avoidance response, and what that means is the plants will actually grow taller. We can also see changes in leaf morphology. So the angle that they are going to hold their leaves up, and so instead of being, let's say, flatter, they're going to be more upright. They might have smaller leaves because they're putting more resources getting tall. And all of these changes that occur, and not just with crops, but also with weed species, is in response to neighboring plants. They're trying to avoid being shaded in the future from competition. And what can happen, though, when we think about crops is when they're putting these resources into growing taller and potentially smaller leaves, they're going to be putting less resources into other things, particularly when we think of a grain crop, so corn, soybeans, dry beans, peas, wheat, these plants which produce grain that's harvested, less resources are going to go into that grain. And so you might have a decrease in yield just because these weeds are nearby. And these weeds are nearby, and this response can occur when the weeds are very small and at a point where they're not actually competing for resources yet. And so what can happen in a farmer's field, for example, is you might control the weeds when they're very small. So they emerge, you're through tillage or through an herbicide application, you're gonna kill all those weed species off. But they're present for just long enough to alter the red to far red ratio, reaching the crops, and that might trigger the shade avoidance response and lead to decreases in yield or yield potential, even without any resource competition taking place.
Can you explain how the shade avoidance response ties into your research?
Yeah, so we've got a couple projects we're looking at this, but one of them is we just finished actually. It's currently being prepared for publication from a former grad student, Clint Byerman, and what we're looking for is how long you need to keep the crop weed free to preserve maximum yield. And this is a long time old concept in weed science. It's been done for a long time. And so what you do is you'll start weeding a plant with a hoe. You won't use any herbicides, and so it's a very time-consuming experiment. But you'll keep weeds out of the plot for the whole season, and then you might start. In this case, it was dry beans. So when the dry beans hit the first trifoliate, so the first set of trifoliate leaves that come up, we'll start weeding then. So we're allowing a few weeks of weeds to be present, and the next time we might start at the sixth trifoliate. And so what we see is as you let weed competition go on longer and longer and longer, the yield goes down, and that's not very surprising. But one thing that we did with this experiment is in half the plots, we had the same amount of weed-free periods, so we're removing these weeds by hand throughout the season for different lengths of time. But for half the plots, they received what we call a soil active herbicide treatment at planting. And so this was a pre-crop emergence. So before the crop emerged, we put down an herbicide that's active in the soil, and it controls weeds after they germinate. And so that's when the roots first emerge from the seed, but before those plants emerge from the soil. And so those plants never actually come out of the soil. Those weeds never come out of the soil. And when we compare the weed free, so the whole season we controlled all the weeds through hoeing, when there was this soil active herbicide applied, which only provided weed control for about the first 4 weeks of the year, that yielded higher than when we came in every, let's say, 2 to 3 times a week and controlled the weeds. And so we were literally going out there with a hoe 3 times a week. The weeds never got taller than a 1/4 inch. But just that small amount of weed emergence that would happen, let's say, between a Monday and a Wednesday, was enough to get a decrease in the yield. Now, it's not a large amount. It might have been 5% of the yield that we got from the season-long weed-free with the pre-emergent herbicide. But what we're seeing is having this herbicide that controls weeds while they're germinating applied at planting actually provides some yield benefits just because of the shade avoidance response. So we're preventing, through the use of herbicides, weeds or crops from responding to these changes in light quality caused by the weeds being present. And so that's one example, is that we're actually seeing the use of soil active herbicides applied before crops emerge as preserving yield season long, even when we remove all the weeds and the other treatments. And this gets related to some other projects we have. So one of the things we're doing right now in dry edible beans, again with my graduate student Joshua and Miranda, is we have most programs in dry edible beans. You apply these soil active herbicides at planting. They wear off after about 4 to 6 weeks, and then you'll apply. Once the weeds come up, you'll apply an application of herbicides that control weeds that are emerged. And these treatments, because of herbicide resistance, no longer controlling one weed in particular, Palmer amaranth, in our area. So we have to. What else can we do? So what we're doing now is we're applying these same herbicides that are applied at planting, but we're applying them, let's say, 3 to 4 weeks after the crop emerges, and so we're overlapping these residual herbicides. And so the goal is to never let that herbicide that's applied at planting dissipate in the field where it's no longer providing control. And so we have this overlapping residual herbicide that's active in the soil, and we can extend that control from 4 to 6 weeks at planting to maybe 6 to 8, maybe even 10 weeks after planting. And so what that means is we're preventing the weeds from ever coming up in the soil, and that means we're probably not having actual crop competition when we use these post-emergent herbicides, but that control weeds that are already emerged. But those treatments may not be preventing the shade avoidance response, and not only in dry beans, but I've personally there's a number of corn products out which have a high amount of activity in the soil, and products like Acuron, Resicor. There's a few others as well. I'm not trying to be particular in any herbicide brand, but those herbicides, you apply them, let's say at planting of corn, and then you can apply them at V4, the fourth collar stage on corn, and basically you're keeping that crop weed free all the way up until pretty late in the season without ever having to control emerged weeds. And so this is just another argument for why these soil active herbicides may be quite a bit better than herbicides that control weeds after they emerge, because we are not only preventing competition, but we might be preventing the shade avoidance response as well.
Thanks, Nevin. Well, folks, today we talked to Dr. Nevin Lawrence about weed competition and the shade avoidance response, and how those two concepts tie into his research here at the Panhandle Extension and Research Center in Scottsbluff. Join us next time as we continue to look at Nevin and the other researchers' projects over the course of the growing season. Be sure to like this video, comment below, and subscribe for more updates. Find us on Twitter at @thefarmsci-ed, and visit our website at farmsci-ed.com for transcripts and other information about this program. Have a good one.